Hey everyone, Dr. Yu here. Today we're going to move on to the next topic, which is about atomic structure and the periodic table. This is what you are expected to know. The first two items are very similar. Basically, it's about the different parts of the atom, but you may have noticed that the first one says label the different parts of the atom, right? So TEAS may show you a diagram. They may label the different parts as A, B, C, D, and you need to be able to identify a specific part. Next, you need to be able to describe what an ion is and some of the characteristics about ions. Last, using a periodic table, you should be able to identify the number of electrons and protons of a given atom or a given element. Now, know that on TEAS, they will give you a digital periodic table. So don't worry about memorizing anything. You will have the periodic table as a reference to answer the question. First, let's look at the structure of an atom. So let's look at the diagram first. There are two components, two parts in an atom. The first part is this nucleus. So this is part number one, and it's known as a nucleus. There are two subatomic particles in the nucleus, and they are protons. If you look at the table, I made a table to list all the different parts. And neutrons are also in the nucleus. So those are the two subatomic particles located in the nucleus. All right, now that's a part one, the nucleus. Part two refers to the electrons that are kind of flying in high speed around the nucleus. So they surround the nucleus and they're moving in very high speed outside the nucleus. So that's the two parts. So part two is the electrons outside the nucleus. All right. Now, each subatomic particle has its own characteristics. So you need to know a few. For example, the location of those different particles, you already know. And next is the charge. Each proton will carry one positive charge. Neutrons do not have any charge, so they are electronically neutral. They have no charge. Electrons carry negative charge. So again, each electron will carry one negative charge. So you can see that overall, an atom is neutral, right? Because the positive charge from the protons and the negative charge from the electrons, they cancel out. Okay, now the third one is a mass or weight, to the same thing. Now, only protons and neutrons, the two types of particles in the nucleus, have a mass. So they each weigh 1. Now the unit is just AMU, so that's atomic mass unit. The electrons, they're so tiny, they don't weigh much, so their weight or their mass is negligible. All right, so when you talk about the atomic mass of an atom, you only count the number of protons and the number of neutrons. Okay, so only these two subatomic particles count toward the weight of the atom. So when we talk about weight, make sure you ignore electrons. It doesn't matter how many electrons are in the atom, we do not count their weight. Okay, so here's some equations that you need to know. We talk about mass, right? Atomic mass equals the number of protons and the number of neutrons. For example, if an atom has 7 protons and 7 neutrons, the atomic mass of that particular atom is going to be 7 plus 7, which is 14, right? Now, maybe this atom also has 7 electrons, but again, remember, we do not consider electrons in calculating atomic mass because the electrons are so small, they barely weigh anything, so ignore their weight. Okay, next one, number of protons equals a number of electrons. We talk about the atom as a whole is neutral. That's because the number of protons is the same as the number of electrons, so that all the positive charge carried by the protons equals the negative charge of all the electrons. So they cancel out. Atoms are neutral. The last one I just added to here. We haven't talked about the periodic table yet, but once we get there, you will see that all the different elements are put in order on the periodic table. And that order is based on the atomic number. The atomic number is based on the number of protons, right? For instance, hydrogen has 1 proton, so that hydrogen is going to be the first element on the periodic table. It has an atomic number of 1. Next one, helium. Helium has 2 protons, so helium is going to be the second element on the periodic table. Its atomic number is 2. All right, now let's look at isotope. Isotopes actually have a lot of applications, not just in biology, but also disciplines as well, physics, chemistry, paleontology. Okay. So isotopes are actually the same element. So they have the same number of protons, right? The number of protons is almost like the number of chromosomes for different species. So each element has its own unique number of protons. So based on the number of protons, you can identify which element an atom is. Okay? But they do differ in one thing, and that's the number of neutrons. Now, are they going to be differ in the number of electrons? No, right? Because the number of electrons has to be same as the number of protons, right? So if all the isotopes have the same number of protons, that implies that they're going to have the same number of electrons. So the only part that they can be different is the number of neutrons. Look at this diagram. This is all the isotopes for hydrogen element. You can see that this is protium, deuterium, and tritium. I actually have done some work on tritium, the concentrations of tritium in water and how much tritium can accumulate in aquatic organisms. Over here, the number on the lower part that indicates the number of protons. Oh, I probably should use a different color. That's the number of protons. And here, so you can see they all have a number of 1, right? All the hydrogen isotopes have 1 proton, but the number here differs 1, 2, and 3. The numbers on the top indicate the atomic mass. And again, atomic mass is the sum of the number of protons and number of neutrons, right? So based on these 2 pieces of information, this is the number of protons, you can actually figure out the number of neutrons, right? So for protium, the number of neutrons is going to be atomic mass, which is 1, minus number of protons, which is also 1. So in protium, there's no neutrons. And you can see, right, in the diagram, in the nucleus, you only have protons, right? There are no neutrons present. So it is possible that there are no neutrons in the nucleus. For the second isotope, deuterium, this is the atomic mass, right? Number 2, and number 1 indicates the number of protons. So again, number of neutrons is going to be 2 minus 1, which is 1, right? So you can see in the diagram, there's 1 neutron present in the nucleus. For tritium, number of neutrons is going to be 3 minus 1, which is 2, and the 2 neutrons are right here. Okay. Now, I want to mention real quick, if you go back to here, to this diagram, in case there's a labeling question, you can see that these 2 subatomic particles are positively charged, right? So you can immediately figure out that these are going to be the protons, right? Because neutrons are no charge. They don't carry any charge. They are neutral. And these positively charged particles are going to be protons, and the other particles that are neutral are going to be neutrons. All right, and then the much smaller particles surrounding the nucleus are going to be the electrons. Next, let's look at ions. Ions are atoms with a positive or negative charge. We talked about atoms earlier, and we determined that atoms overall are neutral, right? Because the positive charge from the protons and negative charge from electrons, protons, negative charge from electrons, they cancel out. But atoms may gain or lose electrons, and this is going to kind of break that balance so that atoms are not neutral anymore. They may be positively charged or negatively charged. At that point, atoms will become ions. Okay. Now, when the atom loses electrons, because the electrons carry negative charge, right? So if the atom loses electrons, they lose that negative charge. So the ion, the newly formed ion, is going to be positively charged. With the same logic, if the atom gains electrons, so the newly formed ion is going to be negatively charged. So you need to kind of understand the relationship. If you lose electrons, you become positive. If you gain electrons, you become negative. There are lots of examples of ions in our daily life, in our body. Sodium, chloride, calcium, we touched on, I think, all of them when we went over anatomy and physiology. There are two terms here. Cations are positively charged ions, and anions are negatively charged ions. I always give students this kind of trick to remember what cations and what anions are. Cations, think of, even if you're not a cat person, kind of force yourself to think that cats are very warm, very positive. So cations are positively charged ions. Anions, it's written kind of like onion, right? The spelling is similar to onion. And when you cut onions, onions make you cry. So when you cry, that's a negative thing. The anions are negatively charged ions. Ionic bond is formed by electron transfer. What is electron transfer? That's between two atoms when one atom gains electrons and the other atom loses electrons. This atom, the one that loses electrons, donate or transfer the electrons to the other atom. Right? So that's basically electron transfer. And the electron transfer will result in a positive ion. Right? You can see here, this is going to be the positive ion. Now, if you lose electrons, and a negative ion, if you gain electrons, right? You gain the negative charge. Now you are negatively charged. The chemical interaction between these two ions are going to be the ionic bond. Okay, so once that electron transfer occurs, this forms this ionic bond between the positive ion and the negative ion. Okay, so that's ions. Next, let's look at the periodic table. Now you can find the periodic table very easily on the internet. There are so many images of periodic table, and this is just an example that I found online. Usually the different regions are color-coded, indicates different groups of elements. The elements are organized and displayed, like I said, according to their atomic number. Right? Starting from hydrogen, you can see this is the atomic number. Hydrogen is the first element, helium the second, and lithium, number 3. And that's because lithium has the 3 protons, and so on. There are some common elements we use in biology, anatomy, and physiology. We talk about carbon, right? Carbon has 6 protons, so it has an atomic number of 6. It's the 6th element on the periodic table. 7th element, nitrogen, and you can see oxygen is the 8th element. Chlorine, so you can look at the periodic table and figure out that chlorine is the 17th element. So chlorine is going to have 17 protons, and it's going to have 17 electrons as well, right? Remember, the numbers have to be the same. And over here, that's the atomic weight, right? So you can see the atomic weight is 35.45. Now, the periodic table is arranged in a way that makes it easier to kind of figure out the chemical reactivity of an element. So you can see these elements are arranged in rows, right? That's one row, or they're arranged in columns. Now, all the elements in the same row, they have the same number of electron shells. But we're going to focus on all the elements in the same column because these elements have the same number of electrons in the valence shell. What is a valence shell? It's the outermost shell. This is what an atom looks like. We already know that there is a nucleus in the center, and protons and neutrons are located in the nucleus. And outside, you have these electrons. Let me use a different color. So maybe there are 2 electrons flying in this orbit. Know that electrons have a different energy. The electrons with the lowest energy level are going to be the closest to the nucleus. So these electrons have the lowest energy level. For electrons that have more energy, they can fly, a little bit further away from the nucleus. So they are going to occupy another shell or orbit. Orbit, or sometimes we call it shell. If that's the only 2 orbits or only 2 shells for this particular atom, then we are going to call the outermost one, which is the second one right here. This is going to be the valence shell. All right. Okay. So all the elements in the same column have the same number of electrons in the valence shell. And that's a very important piece of information because the number of electrons in the outermost shell determines the chemical reactivity of an element. Why is the number of electrons in the valence shell related to chemical reactivity? So we need to talk about this octet rule. Except for the innermost shell, which can hold up to 2 electrons. You can have 1, you can have 2, but that's it. It cannot hold more than 2 electrons. But the other shells, all these shells, they can hold up to 8 electrons. 8 electrons, E4 electrons. In this shell, if you can get to 8 electrons, the atom will be energetically stable. Now, atoms have this tendency to get to the stable state. So they want to have 8 electrons in the valence shell. So that's a very important rule that atoms will follow in the nature. But what if there's only 1 shell? The only 1 shell now counts as the valence shell, right? So it can't hold up to 8. It can only get to 2 electrons at maximum. So how does the rule work? If the atom has only 1 shell, then the atom is stable when you have 2 electrons in that only shell, because that shell is both the innermost and the outermost shell, right? So it can only hold 2 electrons at maximum. So when it gets to 2, then the atom is stable. So there's a little bit exception. If you only have 1 shell, you are stable at 2 electrons. But if you have more than 2 shells, then the outermost shell should have 8, right, before the atom is energetically stable. All right, now TEAS may give you examples of elements or atoms, and then you need to figure out what's going to happen to this atom? How is this atom going to behave, right? And the basis to answer that question is you need to figure out how many electrons are in the valence shell, and the atom is going to behave in a way so that it can satisfy this octet rule. All right, now before we can figure out, in order to figure out how many electrons are in the valence shell, we need to determine how to do the electron configuration, right? Figure out how the electrons are distributed in the different shells. Let's look at potassium as an example. If you go to the periodic table, you need to be able to do this on your own. I already tell you the atomic number is 19, but still go find a periodic table and find potassium and make sure and confirm that the atomic number is 19. The atomic number is based on the number of protons. That means potassium atom has 19 protons. Based on that information, you can also figure out that potassium atom has 19 electrons, right? Because the number of protons, the number of electrons are the same. So now let's fill the electron shells with these electrons. Let's do the innermost shell. Innermost shell can hold up to 2, right? So if you have more than 2 electrons, you can put 2 in the innermost shell. It will get to that maximum capacity. Now let's fill out the next shell. Next shell can hold up to 8, right? So if you have 8 available for this shell, it will definitely hold 8 electrons. So that's 4. Okay. So now we have 2 electrons plus 8. Okay. Now let's fill the next level. We have 19 in total. We have used the 10, so we still have 9 left. That means we can definitely put the maximum number of 8 in the next shell. Right, so we're going to do 8. And this leaves us just 1, right? So this is 18. So that means we have 1 electron that we need to assign to the electron shell. So we need to draw another shell, but this shell, unfortunately, has only 1 electron. Now, is potassium stable, energetically stable? No, right? Because it does not satisfy the octet rule. Instead of 8, it has only 1 electron in the valence shell. So it's far from being stable. So in order to achieve that stable state and satisfy the octet rule, then potassium tends to just lose this electron to some other atom. Because when that electron is gone, then the next, let me use a different color, the next shell now becomes the valence shell, and there are 8 electrons in that shell. So this satisfies the octet rule, and the potassium atom, which is now potassium ion, right, because it loses an electron, is stable. So potassium ion is pretty stable.